All right, welcome back to the study hall for February 2nd. Going to do some quant problems. They're all data sufficiency today. So again, we do assume a certain level of familiarity with data sufficiency on your part. These problems have to do with number properties and or percents. So just to show the copyright info again. Today's problems again are mostly from our materials, mostly, but not necessarily entirely. But if we don't attribute the problem to a source, then it's from the free GMAT prep. So just that's where we do get the majority of the problems for these things. Okay, and don't forget, when you have a multiple choice question, this is where you answer it. All right, let's go ahead and do one. Remember, it's data sufficiency. So if anybody needs the answer choices written out, I could put that on the board, but we can't explain what sufficient means and what not sufficient means and so on. But if anybody does need the 5 choices that would appear on the screen, then let me know and I can post those. If not, then go ahead and get going on it. In fact, I'm just going to go ahead and post those anyway. Okay, here are the answer choices. You can post that on the board. Give you a little bit to solve the problem. Don't forget to mark the multiple choice answers in the appropriate place, as indicated in the picture here. I'll give you a little bit of time for that. There are 7 answers already, and none of them are correct. So if you have already answered the problem, you are wrong. You should rethink it. Remember, don't rush through these things. If you think you can solve them in like 20 or 30 seconds, then you're going to get burned. Okay, if you don't have an answer, you should definitely pick one soon. Remember what time management means on this exam and what it doesn't mean. I mean, what time management means is just not staring at the board and also not doing steps that have no purpose, right? Like you probably have all these bad instincts left over from when you had partial credit awarded on tests for school, you know, where you would just do random stuff and hope that you got points. Remember, there's no partial credit on this exam, so the only thing you're doing if you do that is you're just wasting time. So that's pretty much all that time management is. So if you haven't picked a choice yet, you should pick one. That means Lynn, Duan, Rishab, Satya, Tobo. And it looks like Zoom. If you don't have an answer yet, you should pick one. Wait about another 15 seconds for you to do that. Okay, let's talk about the problem. And the answers are kind of all over the place. I don't normally post answer distributions, but it's kind of interesting this time. We have like 3 answers that are most popular, which are B, C, and E. The good news is the correct answer is actually one of those. But remember, the first like 9 people who answered this question got it wrong too. So just keep in mind that the problems are generally like that. I mean, if you think you're going to solve one of these things in 15 or 20 seconds, you are generally going to be incorrect about that. Let's talk about it. I mean, also, we've had plenty of previous study hall sessions about the topic of goal setting in data sufficiency, but you have to make sure that you have the right goal, which in this case is that question. So, dangerous shortcuts. Not sure what you're talking about, but okay. In general, you shouldn't really look for shortcuts anyway on these things. You should make sure that you're addressing the question. But, I mean, maybe if you can explain what you mean by shortcut, that would probably help, but I don't know what you mean. Okay, this is the goal. The goal is this question. So you should not expect to find A and B. You should not even really expect to find any properties of A and B, because those are not the question that is here. So, and remember the thing, we've actually had, I want to say 3 or 4 sessions on very specifically this topic of setting goals in data sufficiency. But if you think you're going to find out about A and B individually, then you have already got this problem incorrect. So just keep this in mind. Like whenever a data sufficiency problem asks a weirdly specific question, I mean that is definitely a weirdly specific question. Whenever a data sufficiency question is weirdly specific, I mean, this definitely qualifies, right? You have these expressions and an inequality. This is not just like, what is A or B? What are the signs of A and B? No, it's this. Whenever you have this kind of thing, just make sure that you address this and do not try to rephrase these questions. Do not do it. If you do, you're probably going to rephrase it into something different that does not work out the same way. So don't even do it. Leave the question exactly the way it is. Because that's the whole point. The point is that this super specific question is what you're going to find. You should expect to find the answer to that exact question. And you should expect not to find anything more specific. So in other words, you should not expect to find A and B. You should not expect to find signs of A and B. Nope. You should just expect to be able to answer this. Keep this in mind. Okay. Let's talk about this. Notice in statement 1, you don't have anything about A, although that doesn't guarantee that the statement is not sufficient. Like, you still have to actually investigate this. Like, some people will look at statement 1 and will say that's automatically not sufficient because because A is not in it. That's not a thing. Give me a smiley face if that makes sense. Like, even though A is not here, this statement still could be sufficient or not sufficient. I mean, just as a super quick example of that, it's not this problem, but if I said something like, if M and N are integers, is M and even? And then if I told you that one of them was even, then this would actually be sufficient. even though n is not mentioned. I mean, your smiley face, if that makes sense. Like if you knew this and you knew these things were integers, then you would be guaranteed that mn would be even. So if you looked at statement 1 and just thought I can automatically say that's not sufficient, that's not right. I mean, as it turns out, statement 1 is not sufficient, but you actually have to prove that. You actually have to work through it and show that's the case. So, okay. For statement 1, let's test some cases. I mean, it should be pretty clear that you're not going to be able to do algebra here because signs are an issue. Like this is an absolute value sign, which deals fundamentally with positives and negatives differently. So you're not going to be able to manipulate this algebraically, and you're definitely not going to want to try to solve this algebraically. I mean, you should know what this means. Like somebody tell me what types of, like what numbers, what ranges of numbers could be in. And make sure you can translate this statement into actual ranges of numbers. Yeah, either more than 1 or less than -1. Joey gave some specific examples. But just make sure you know what this generally means. This means that either b is greater than 1 or b is less than -1. Like this is the kind of thing that you need to be able to do immediately, by the way. Like if you cannot translate this statement into that version pretty much right away, then you should make a flashcard so that you can next time. Keep that in mind. Okay. Let's plug in some cases. We're not going to be able to do algebra here. And one thing about data sufficiency that you should also know is that there are basically 2 approaches to it. Like either you're going to use some type of algebraic or theoretical approach, or you're going to test cases. It's pretty much all you can do, as opposed to multiple choice problems where you have lots of different ways you can do those. You can pick smart numbers, you can back solve, you can do all kinds of stuff like that. So that is an absolute value sign. But this is, if getting from here to here is not clear, then that's in our strategy guide. I think it's in our foundations book too. But this should be routine, getting from this to this translation. That should be pretty much automatic. So if that's not clear, then go ahead and refer to the algebra strategy guide, where they'll go into that in some more depth. Okay. You can also Google things like absolute value inequalities. It's pretty standard issue stuff, but you can just read about it and do practice exercises online too. That could also help. In this problem, can't solve this with algebra, so we're going to end up testing cases. Let's do it. So statement 1, let's test cases. Let's do it. So we need to pick B and A. We need to make sure we pick B so that it's in those ranges. And then we need to find AB. And then we need to find A over B. And then we want to try for both possible cases of that statement. Right? And then you should write down conditions that are on these things too. Like here, the condition on B is that it has to be either more than 1 or it has to be -1, less than -1. That's supposed to be -1. There we go. Just write that down so you have to remember it. Okay. So let's try a B. Let's see. Joey mentioned 3. You're probably going to try a positive number first, right? So if B is 3, then we can make A 1. Then AB would be 3. And A over B would be 1/3. So 3 is greater than 1/3. Now what are we trying to do with our lives here? Like now that we've made AB greater than A over B, So you want to try to find a thing that is a no, and remember, make sure that you don't think about the word no. Yeah, think about less than or equal to. This is one of the biggest deals that gets in people's way, is that they're still thinking about the words yes and no. I mean, make sure that you have a goal that is more concrete than that. I mean, you can put this here if you want to, just to reinforce the idea. But make sure that you know what you're specifically trying to do, right? So this would be, yes, it's greater than. But make sure that you are not thinking about yeses and nos as goals. So like now we want it to be less than or equal to. So how are we going to do that? Well, I mean, if we just keep b as 3, yeah, we're going to take a negative number, right? So if a is -1 instead of +1, then you're going to have the same numerical values, but they're just going to be negative. So -1, still 3. Now this is going to be -3, and now this is going to be -1/3. So, or you could make b negative, that would work too. So that's less than or equal to. And so this is a no to the question. That's not sufficient. Any questions about that? If you have questions, go ahead and type them. And that's comfortable typing. We're not doing statement 2 right now. That's not what we're doing. We're doing statement 1. And remember what the goal is. I mean, again, this is the biggest issue that people have with these data sufficiencies that are yes, no, or what have you, is that people don't concretely know what they're trying to do. I mean, you are on statement 1 until you either make both of these things happen, or you become certain that you can't make both of them happen. Like if you kept getting greater than, greater than, greater than, greater than, greater than, then eventually you would quit and say, I can't do it. But yeah, we're still on statement 1. Okay. I mean, this is, you could also write b squared is greater than 1, although I would not call that simplified. I mean, that's just as unsimplified as this. I mean, if you had that, you would still want to turn it into this, because like this is what you have to know. You have to know that you can pick b in these 2 ranges. Like it's, if you could write that, you could write b squared is greater than 1, but that would still be unsimplified. That would still not tell you what you really need to know, which is this. So, okay. Don't worry about more time consuming. If you think of something to do, you should just do it. I mean, we're talking about differences of like 5 or 10 seconds here. So do not ever hesitate to do something because you think it is time consuming. That is the biggest mistake that you can make on this entire exam. You should just do stuff, and you should not do stuff. Don't try to guess how long stuff will take. That is the best way to get a lower score. Let's talk about statement 2. So, I mean, statement 2, we got to interpret what statement 2 means. So what does statement 2 mean? Like you might need to investigate this for a little bit. What does that even mean? Because you can't really pick random values right away that do this. Like this is going to need some interpretation. But in general, when they give you statements like this, as opposed to questions, when the question is weirdly specific, you should not touch it and not try to rephrase it or anything like that. When the statements are like that, there's probably some simpler key to that. It's very asymmetrical. So, because the difference is you're not trying to pick numbers that do this. This is the result. But for you to be able to use this statement, it has to mean something simpler than that. So you could push this over there and make it negative, but that's not really any better. In fact, that's actually kind of worse than this. if you push this over here, it's not the same as the question. I mean, if you move this over here, then it becomes negative sign in front of it. So, in other words, it's unrelated to the question. I mean, Laura, you could write that, but that's not intuitively any more meaningful than this. In fact, it's probably less so. I mean, you could write that. Doug, that's incorrect, because you can't just magically move AB over there. If you moved AB over here, it would have a negative sign in front of it. But you could move one of these two pieces over there, but it's not really going to help you. I mean, if you look at the result, it's not going to have any intuitive meaning that this doesn't have. But like, let's think about these things. Like, what do we know about? Like, we should be thinking about signs already, because from statement 1, we have this absolute value thing. So, like, among other things, this should tell us, hey, we need to be thinking about signs in this problem. So that's what that should tell you. Give me a smiley face if that makes sense. So if that's a thing, if it's a theme in the first statement, it should also be a theme in the second statement. You know, it's not going to become a totally different problem with different priorities. So it's not assuming. We're not making assumptions. Like, if you're going to say that, you have to prove it. But what do we know about the product of A and B? We know that when is it positive? We know that it can't be 0 because they told us it's not. So when is the product of A and B positive? Yeah, they have the same sign. They're both positive or both negative. And remember that neither of them can be 0. I mean, they guaranteed that up here. That's what that tells you. Neither A nor B is 0. That's the point of telling you that. So, I mean, if A and B had opposite sides, this would be negative, and so would that, is the point. So you divide or multiply two numbers with opposite signs, you will get negative. So, you get a smiley face if that makes sense. Like, both of these parts are negative if A and B have opposite signs. But if they have the same sign, if they are two negatives or if they are two positives, then AB is going to be positive, and so is A over B. So both of these are positive if A and B have matching signs. So we need this to be positive. I mean, that's what the thing tells us. So A and B cannot have opposite signs, and they have to have matching signs. So basically, this statement is just a really ugly, horrendous, awful way of telling us that A and B have the same sign. Give me a smiley face if that makes sense. It's basically all this statement is at the end of the day. It tells us that A and B, this is just a very indirect way of telling us that. A and B are both positive or both negative. That's what it tells us. Okay, but that's all we know, right? So other than that, we don't know the values of those. Let's get rid of this thing over here. So let's test some cases for that statement. For statement 2. Same kind of thing. And then we're asking the same question about them too. So is AB greater than A over B? All right, let's do it. Remember, this time you can't, we can keep this case from statement 1 because A and B are both positive. The first case that we tested, we can keep that. So, and you should try to do that. You should try to keep cases that you tested before just so that you don't have to waste the time doing extra work. So give me a smiley face if that makes sense. Like A and B are both positive here. So, and you need to keep the same sign. It doesn't have to be positive, but these have to be the same sign. How can you get this to be the other way? How can you get AB to be less than or equal to A over B? You can't use opposite signs because that's the whole point of statement 2. That is actually the only thing that statement 2 tells you is that you can't use opposite signs. You could use fractions or you could just use 1, right? There's nothing stopping you from just using 1 and 1, which might be the first thing that comes to mind. You can just be like, okay, I'm going to let A be 1, I'm going to let B be 1. So then AB is 1, and A over B is also 1. You can do that. That's totally a thing. You could also use a fractional value for B if you'd rather. Although, yeah, whatever you'd rather come up with. Like if you did 1 divided by 1/3, for example, like 1 times 1/3 is 1/3, and 1 divided by 1/3 is 3. You could also do that either way. So you could also use a fractional value for B. It won't make any difference if you use a fractional value for A. And try it on your own if you have to. But that'll get you both of those. So this is not sufficient. Statement 2 is not sufficient. That's supposed to say 2. Let's fix that. All right. Now we got to combine the statements. How are we going to do that? Well, you can still use that. You can still use that case that we've got. So let's combine them. Combine the statements. You can still use that case of 1, 3, 3. I mean, that's still going to work. So, sorry, I meant to put that divider up here. Because that satisfies B in the range we need for statement 1. So we can still reuse this. But now what? What are we trying to do? So if you make A a fraction, let's see what happens if we try that. Because B is not allowed to be a fraction anymore. At least it can't be a fraction less than 1, which is what people usually mean when they say fraction. Because that's what statement 1 rules out. So, I mean, let's write the conditions that we have to satisfy. Because otherwise we have to try to remember it, and nobody wants to do that. Right? But A has to be the same sign as B. And B has to be either greater than 1 or less than -1. So if we try negatives, you're going to very quickly realize that it doesn't make any difference the numbers are negative. Like if we throw in -1 and -3, then you still get the same result. And you're going to see pretty quickly, if you could plug in negative numbers, but you are always going to get exactly the same thing that you would have gotten if you had just plugged in the positive values. So give me a smiley face if that makes sense. Like, it's plugging in negatives isn't going to help us because we're going to get the same result as we would have gotten if we had plugged in positives. So we might as well just try positive. If we try a fraction for A, maybe it's like 1/2 and it's 2. Yeah, 1/2 times 2 is 1. And 1/2 divided by 2 is 1/4. That's still greater. If you keep trying this, you're not going to get less than or equal to. And I mean, remember, if you just don't get that after a while, you should trust that you're not going to get it. But if you think about it conceptually, like this is multiplication by B right here. And this is division by B. And if B is bigger than 1, then multiplying by B will make something bigger. And dividing by B will make it smaller. That's what it does with positives. And remember that negatives will just do the same thing. So eventually, after enough plugins, you're going to discover this. But AB is always going to end up being bigger than A over B. So it's going to be always greater than. So you can't, if you have, that would require B to be +3. Remember, you can't have opposite signs for A and B. Like you're trying to use this case, but you can't use this case because A and B have opposite signs. I mean, if you play around with these values, I mean, you're going to realize really quickly that plugging in negatives does nothing, because if I plug in minus this and minus that, then it'll be the same as if I plugged in positive this and positive that. You'll see. I mean, if not, just play with numbers until you figure it out. Remember, you have lots of time to plug in values and see what they do. I mean, you have lots of time to investigate this. You should not rush it. If you're not sure what's going to happen when you plug in certain numbers, just plug them in and see what they do. But just make sure that you write down conditions. I mean, honestly, if you are plugging in cases that don't apply, like if you thought you could use -1 and 3 here, it means you're not writing this stuff down. That's what it means. It means you're making yourself try to remember these things. Don't do that. Do not try to force memory. You should just write down all the things so that you can look at them and refer to them. And then you're going to get, this is always going to be greater than. You're not going to be able to get less than or equal to. So together, it's sufficient. And that's C like cat. And we notice about goals, back where we set up here, like you get the answer to this question. Like you find out that AB is always greater than A over B. You do find out that. Notice that you literally don't find out anything else at all. Like A could still be negative or positive. B could still be negative or positive. Like A could be greater than or less than B. Like you literally do not find out anything at all except for the goal of the problem. Like this, I cannot emphasize this enough. Like if you try to rephrase a question like this, it's going to bite you in the butt. Don't do it. Leave the question alone, because that is almost certainly going to be the thing that is addressed, and nothing else is going to be addressed. Any questions about this problem? I mean, also notice the logistics and the framework and the organization. I mean, that's the biggest deal. Like if you got lost during testing cases, it means you didn't write down enough stuff. I mean, the rule that I use for that's pretty simple. Basically, the rule is if you have to remember anything while doing anything else, you need to write down more stuff. So like if you had to remember that B was in this range, or if you had to remember that A and B had the same sign, it means you should have written it down. Do not make yourself remember stuff. That's a very, very, very big deal. So, worth writing down. If you ever have to remember something while doing something else, you're not writing enough stuff down. Okay. I mean, you would be silly to think that you have to solve every problem in 2 minutes, because 2 minutes is the average time. You're going to have just as many problems over 2 minutes as under 2 minutes. So, I mean, just think about that for a second. I mean, you definitely do not have to finish every problem faster than average. So that is a non-concern. Other question from statement 2, it doesn't. I mean, the question is totally different. I mean, I guess I'll get that in your slide. I mean, the question was, let's copy the question too. The question was this. This was the question. And these are two completely different things. So, I mean, this is not the same as this. So it's not a definite no to the question. I mean, I don't know where you're getting the idea that it is, but just if this is not clear, then what you should do is you should just mess around with specific numbers at home. Just don't worry about these fractional expressions, but like this and this are completely different things. It's possible for either one of these to be true while the other one is false. So, like, just play around with numbers at home and find numbers that make these true and true, true and false, false and true, and then false and false. I mean, you should be able to do all of those. And then you'll see. So, but I mean, in general, also, like this is obviously a very meaningful statement. On the other hand, this is not. This is a completely meaningless statement intuitively. I mean, if you see this, if you got that second statement, what you should do with it is you should turn this into this. Because then that's actually intuitively meaningful. Like, you can think about when two numbers add up to be more than 0. Like, that's pretty, you should have intuition about that. Like, either they're both positive, or one is positive, one is 0, or there's a bigger positive and a smaller negative. You can figure that out by just looking at this. You definitely won't figure that out by looking at this. So even though these look similar, this is meaningful and this is not meaningful. And the way you figure that out is just to play around with these things when you review stuff. So yeah, play around with those, see if you can get it to work all those different ways. Okay. Let's move on to another problem. Let's see. How about how about this one? Don't forget that this says n different integers. If you need to write that down on your paper to remind yourself that it is true, then write it down on your paper to remind yourself that it is true. But you can't forget that these have to be different. Give it a shot. Put the problems on the board if you need. I'll put the answer choices on the board if you need them. may actually be the only other problem that we get to today, but we'll see. We have a few of these left over that we can, if necessary, push to the following study hall. And don't forget where you put the answers to multiple choice questions. Those go here. Okay, and then also don't worry about this idea that you need to finish everything in 2 minutes, because you clearly don't. Also, you should not be timing individual problems. That is a huge mistake. I mean, if you guys are looking at the timer for every problem, remember, you can't just look at a timer. I mean, if you look at a timer, you're going to be subtracting time and recalculating, and recalibrating, and stressing out. Like, every time you look at a timer, you are easily costing yourself 15 to 30 seconds in distraction time. Not worth it, guys. Okay, if you have already answered the question, your answer is incorrect. Everyone who has already answered is wrong. Give you a little bit more time. Guys, there are instructions on the screen for where to answer the question. Do not answer in the chat box. I'm looking at you, person who answered in the chat box. Don't do it. The answer in the chat box is incorrect, by the way. This is also a problem that I made up for our materials, not GMAT prep problem. So, okay, if you are still genuinely working on the problem and still making actual progress, then keep going. If you are not, you should stop and put an answer down. And also don't forget that if you do genuinely get stuck, then you should immediately stop and put an answer down when you get stuck. You should not continue to work because you think that other people are still working. I mean, that's definitely a thing that people sometimes do in class type environments, and you should not do it. Okay, let's talk about it. Well, we have n different integers, and we want to know if they are consecutive. So, really, the question is not super hard to understand, right? Like, the yes to this question is they're all consecutive. And the no to this question is they're not all consecutive. So if you can make both of these happen, then it's not sufficient. Smiley face if that makes sense. Make sure you define that first. If you don't define that, it means that anything you're doing after that point kind of doesn't really have a point. So that's not a situation you want to be in. So make sure you do define this. Okay. Statement 2 is probably less bad than statement 1. I mean, it's at least easier to think about. I mean, the difference between any two numbers in the list is always less than n. Like, let's talk about that. Say we have, let's look at some number of integers. Like, let's say that n is 3. We can start by looking at simple cases. It's a good guideline in general for when you have something like this and you're not really sure how to investigate it. The best way to investigate these kinds of things is usually to look at simple cases. Like, let's say that we have, let's look at 3 integers. I mean, okay. If we actually have consecutive integers, let's just look at a couple examples of that. So, like 1, 2, 3, 2, 3, 4, 3, 4, 5, etc. Like, what's the biggest difference between any of these? Between any two numbers in the list, not any two numbers in a row, any two numbers at all. So the biggest difference is 2. So for all of these things, and you can tell with any list of 3 consecutive integers, that's how it's going to work. So if they're consecutive, yeah, right, the differences are all 2 or less. So yes, they are always less than 3. I mean, if we look at 4 integers, same kind of thing, right? It's going to be the same thing if n is 2. It actually works the same way. Because then the difference would be 1. We have 4 integers, 1, 2, 3, 4, 2, 3, 4, 5, etc. These differences are all 3 or less. The biggest difference you can make is 4 minus 1 or 5 minus 2. Now the other ones are smaller than that. So they're always less than 4. So the point is that these lists are always going to satisfy statement 2. So, and if you look at any number of integers, it's going to be the same way. Like if you have 10 integers and they are consecutive, the biggest difference is going to be 9. So, yeah, if n is 2, it's the same thing. You'll have 2 in a row, and the difference will be 1. So it'll still work. So basically, any list of this type will satisfy statement 2. And it's going to give you yes, all consecutive. So now what we need to try to find, we need to try to satisfy statement 2 with a list that is not all consecutive. Now, consecutive means consecutive. Those 2, 4, 6, 8 are not consecutive. Those are consecutive evens, but they're not consecutive integers. You cannot have, remember the very first thing we talked about here was underline that word. Whoopsie. Can't have a list like 1, 1, 1, 1. Nope, can't do it. I even told you guys to underline that and write it on your paper. Whoops. Do not try to remember these things, guys. If you have to write down all different integers, you have to write that down like 4 different places on your paper, then do it. Let's see if we can satisfy. We got to try to satisfy statement 2 in a way that gives us not all consecutive. So let's see if we can do that or not. Let's see if that's even a thing that we can do. If they're not consecutive, what if they're not. Let's try something like, well, let's try making the smallest possible difference, because we still want to keep the differences under this ceiling, right? So, like 1, 2, 4. But here you have a difference of 3. The biggest difference is 3, which is n. So no, not always less than n. So that just doesn't count. Like that doesn't satisfy the statement. If you try to make other lists that do that, you'll run into the same issue, right? If you have like 1, 3, 4, 2, someone wrote like bigger differences, 2, 3, 10, 2, 3, 5, etc. I mean, you're going to find that if you do not, because notice that if you have consecutive integers, then your biggest difference is always 2 versus n is 3. Or your biggest difference is always 3 versus n is 4. Like, you don't really have any room to spare here. Like, look at these relationships. If you got your eyes open and you're paying attention to this, you're going to realize that you're not going to be able to do this with any integers that are not consecutive. Because if you look at this, like you have no room to move here. Like if you spread those integers any farther apart, then you're going to have a difference that equals n. You'll notice that. If not, you play with lists of non-consecutive integers, and eventually you'll realize it. But if you try to spread these out anymore, it's not going to work. You'll have a difference of at least n. Same sort of thing with this, and same sort of thing with any size subset. So you're not going to be able to do this. Like this set has a difference of 3, this set has a difference of 3, this set has a difference of 8. You can't make a set like this that satisfies statement 2. So if you try, it's not going to work. Smiley face, if that makes sense. So what that means, like all the statements, all the sets that you can make that actually satisfy statement 2 are going to give you this result. You can't get that result. So that means the statement is sufficient, because this is the result that you get every time. Combine it with this observation that you can't get the opposite result. Try, it's not going to work. So statement 2 is sufficient. Okay, now statement 1 is weird. Let's take a look at it. Let's give this another slide. Let's take the problem to another page. Okay, let's look at statement 1. So I'm just going to white out statement 2. We already resolved it on the previous page. Statement 2 is, I might have written it wrong. Did I write that wrong? Yeah, no, it's sufficient. That's right. This statement is sufficient. We can white that out. Let's look at statement 1. The least number is removed from the list. The average is 1 more than if the greatest number is removed from the list. And remember, you can try this both ways. You can try this algebraically. Like this is at least something you can do algebraically. I mean, if you can, it's not the friendliest thing in the world to set up, but it's not horrendous, right? 1, 3. I mean, that would be 1, 2, 3, 4, 5, 6, 7. If you wrote that. I mean, those are still consecutive integers. Those are still 1, 2, 3, 4, 5, 6, 7. So that either it's a set of consecutive integers or it isn't. Like a set list, the order that you put them in doesn't make any difference. So the GMAT will probably give you more language just to make that clear, but you can't. I mean, remember that nothing is going to be haha, we're playing tricks with words and stuff like that. So if you make up counterexamples like the one in the chat box, you should just know that those are not counterexamples. Like, if you're going to find a counterexample, it's going to be something that is mathematically legitimate. It's not going to be like, let's play tricks with the order of things. And make sure you know that's not a thing. You don't ever play tricks with things like order, and you don't ever play tricks with words. If you're doing that, it's the wrong mentality with which to approach this exam. Okay. You can do this algebraically, or you can do it testing cases. Let's test cases first, because we're going to prove it algebraically later. Let's test some cases. Okay, like let's see if we can do it consecutively. So let's use consecutive integers. Let's do 1, 2, 3. Okay. If you take out the smallest number, that gives you a list that just have 1 and 2. You take out 1, so you have 2 and 3. And the average is 2.5. If you take out the biggest number, that leaves you with just 1 and 2. The average is 1.5. So this satisfies the statement and they are all consecutive. So, well, what do we need to find now? Like, is there any point in trying other sets of consecutive integers? There is no point in doing that, right? Because remember what not sufficient means. If you can get all consecutive and you can get not all consecutive, then that's going to be not sufficient. So, I mean, we already got a case where they're consecutive. So, at this point, just make sure that you know this. Trying more consecutive sets is not going to help you here. If you tried -3, I mean, that's still a set of consecutive integers. I mean, again, there's no point in trying that because we already got this case. So again, keep this in mind. Once you have gotten a set that is consecutive, finding more consecutive sets is not going to help you. Okay, let's see if we can, what we need now, I mean, to prove not sufficient, we would need a set of integers that are not all consecutive for which the difference between averages is still 1. I mean, this is the only thing that would be meaningful if we found it. Is a set where they're not all consecutive, but it still satisfies statement 1. We have a smiling face if this makes sense. Because even if you have trouble doing this or actually finding cases, you need to know this. If you don't know this, then there's no point in working the problem. Like if this is not clear to you, then you should not keep working on the problem. You should just guess and stop. I mean, if this is clear, but you need to play with it for a while to resolve this, then that's fine. But if this is not clear, then do not keep working. Do not do it. If you keep working, you are just wasting your time. Because that means you don't even know what you're trying to do. Sure that you know. Like you should be able to program Excel to do this. Like not to pick the numbers. Excel is not going to know how to pick numbers strategically. But once the numbers have been picked, you should absolutely know how to program Excel to tell whether the statements are just yes, no to the question, whether it's sufficient or not sufficient. So if there's any lack of concreteness there, we'll keep working on it. As we try that, let's try non-consecutive sets and see what happens. Like, we get something like 1, 2, 4. Okay. If we take out the smallest number, then we have 2 and 4. The average is 3. And if we take out the biggest number, then we have just 1 and 2. The average is 1.5. I mean, also, you probably didn't even have to test this case, because with this list, the difference was 1. So if you move these numbers farther apart, then it's going to become more than 1. So you also could have just seen that. But if you didn't see that, then you test more cases. So this doesn't even count because it doesn't satisfy the statement. If you try more numbers, you can discover the same thing. If you try like 1, 2, 3, 4, 5, if you those are consecutive. If you try 1, 2, 3, 4, 6, if you take out the smallest number, then you have a list with 2, 3, 4, and 6. That's supposed to be a 6. The average of those is 5 plus 4 is 9, so it's 15 over 4. So that's 3.3 3/4. If you take out the biggest number, then that's 1, 2, 3, 4. And the average is 2.5. Still bigger than 1. So it doesn't satisfy the statement. I mean, you keep trying this for a while, you're going to notice that this always ends up being bigger than 1. And remember, you're not going to find fake patterns on this test. So after enough failures to do this, you can pretty confidently conclude that it's not a thing that you can do. So, but eventually you're just going to keep not getting it until you're convinced. You should become convinced pretty quickly that you can't satisfy statement 1 with anything but consecutive integers. So that means that statement 1 is sufficient. Any questions about that? You can also look at it algebraically, which we'll do in a second. I think there are people typing things now. So let's see what people are typing. Yeah, so the answer to the overall question is going to be G like dogs. One other person typing. In the meantime, let's go ahead and start setting up algebra here. I mean, let's say that, we're going to need variables for the biggest and the smallest things. Like, let's say that let H be the highest number in the set. And let's let L be the lowest number in the set. Then we have these averages. Notice the average is the sum of everything in the set. So let's let S be the sum of everything in the whole set. Let's just see where this goes. So what is a vocal fry? I have no idea what that means. Help me out here. I don't know what vocal fry is. But let's talk about this. And we can't let these be consecutive because then that's not going to prove anything. I mean, let's write this statement algebraically. Let's just do that. The least number is removed. One more than if the greatest number is removed. How do you write the average if you take out the number L? Like, remember, it's the total sum divided by how many numbers there are. So we want the average without L plus 1 to equal the average without H. Okay, we need to write that as an algebraic equation. That's the point. So if we can write this as a general expression, I mean, we don't want to pick numbers, because if we pick numbers, then we might as well just pick numbers. Like, we're back to doing that. Like, what you don't want to do is do algebra, but kind of not do algebra. That's the one thing you do not want to do. So, if you're going to do algebra, you want to make sure to write things in general form, because otherwise there's no point in doing algebra. So, how are you going to do that? Remember, you originally had n integers whose sum is s. Guys, let's not chit-chat in the chat box, please. Thank you. How do you write the average without the number L? Like, what is the sum of everything except L? It's the overall sum minus whatever L is. So, and then how many numbers are there? You originally had n numbers, so it's n minus 1. Don't say 2, because again, you don't want to pick numbers. If you're going to pick numbers, you should just pick numbers. Like, if you're going to pick numbers, don't do algebra. Like, don't do half and half type of approaches. That's what you definitely don't want to do. You want to pick a side of the fence and stay on it. If you're going to test cases, just test cases that are numbers. So that plus 1 equals the average without H. Same thing, you're just taking out H instead of L. So now, what do we want to find here? Like, what difference is the only difference that we really care about? Like, how do you prove whether they're consecutive or not? Like, here, remember, here are consecutive sets on this page. Like, what's the only difference that you have to look at to tell whether the numbers are consecutive or not? So you can't look at differences being 1 unless you are somehow going to look at every single difference between every pair of integers. Because that's, like, if you have a list that's like 1, 3, 4, then or like something like that, then you're still going to have some differences of 1. So let's see, the average, that's actually right. If you take out the lowest number, that's a bigger, thank you. That is correct. So, yeah, it's going to be bigger if you take out the smaller. Thank you for that. So that goes over here. Yeah. Yeah, when you review the problem, you should at least investigate both approaches. Like, sometimes you might have to throw away one or the other of them if it just doesn't agree with you, but you should at least try. Yeah, for sure. Okay, thank you, Laura, for that correction. Yeah, if you take away H, it's going to be smaller. So, but no, we don't care about differences of 1, because like if you were looking at differences being 1, then you would have to look at every single difference between every pair of numbers. But look at this, right? If you, all you have to look at is the difference between the first number, the lowest number, and the highest number. That's all you have to look at. Like if you have 3 integers and this is 2, those are consecutive. If you have 4 integers and this difference is 3, then those are consecutive. And the smiley face, if that makes sense. You just got to look at the difference between the biggest and smallest numbers. Because if they're not consecutive, it's going to push those farther apart. So that's the pattern that you can notice here. Like if the difference, if the biggest and smallest numbers are exactly n minus 1 apart, then everything is consecutive. If the difference is bigger than that, then everything is not consecutive. So yeah, you just need to look at H minus L. So are you solving? You're not. Statement 1 is the given. I mean, this statement 1 is translated into this. You're not solving for statement 1 because that would be running the problem backwards. I mean, you start from statement 1 and you see what you can prove from it. But you're not trying to prove statement 1. Statement 1's a given. You start from this. Like this is the algebraic version of statement 1. And what we want to do is let's investigate H minus L. And if that ends up being n minus 1, then everything is consecutive. That's the whole thing, right? You can investigate enough sets to figure this out. So if you don't think of this, then you just start testing cases and you'll discover this pretty fast. I mean, you don't need to do anything like this. I mean, you can just throw numbers at it and see what they do. But it's always better to have more approaches. So if we multiply by n minus 1, everything, then that's going to give you S minus L equals S minus H plus n minus 1. It just knocks it out of these denominators and then puts it here. So S cancels. And we can add H to both sides. That's going to knock out H over here. And so you actually get H minus L is exactly n minus 1. So that shows you that you have consecutives. They're all consecutive. So that's sufficient. I mean, admittedly, that's a little bit special. That's not the kind of thing that everybody would be expected to come up with. But you don't have to come up with them, which is the point. Like if you just start investigating sets of numbers, you'll discover pretty fast that you can't make this happen with anything but consecutives. So the most important thing, as always, is just that if you get stuck anywhere in this process, that you immediately quit and start testing cases. As long as you do that, you're going to be fine. But if you shove variables around all over town without understanding why you're doing it, then you're not going to be fine. So that's the deal. Okay, we are done. It is right on time. We're going to do some more of these problems next time. Still have a few left in the queue. So we're going to pick up where we left off, do some more of these interesting problems. So next study hall should be in 2 weeks. So that's going to be February 16th. So until then, thank you. And I'll see you on the flip side.